Welcome back. According to the CDC, heart disease is responsible for 1 in every 4 deaths in the United States every year. A big part of the problem is that too much cholesterol in the blood can lead to blocked arteries. The cholesterol gets deposited in the arterial walls, as you see here, a condition known as atherosclerosis.
I don't like the sound of that.
So what does cholesterol and cardiovascular disease have to do with today's topic? Density? Well, the connection is that cholesterol is carried in the blood by low-density lipoproteins, LDL, and high-density lipoproteins, HDL. LDL cholesterol is known as the bad cholesterol because it deposits cholesterol in the arterial walls. HDL cholesterol is known as the good cholesterol because it removes cholesterol from the arterial walls. Since the structures of LDL and HDL are complex, it's hard for us at this point to focus on specifically why LDL is less dense than HDL. But in general, just imagine if you magnified the structure of LDL, the particles you would see would be somewhat spread out, like this, not so tightly packed. But if you could see the particles of HDL, they would be more like this one, everything tightly packed. Let's consider some things you're more familiar with. Let's say you have equal volumes of steel and styrofoam. We know steel has the higher density because its mass is greater than the styrofoam. Steel would be like the HDL and styrofoam like the LDL. Here's another familiar example. You probably noticed that ice floats on water. It doesn't sink to the bottom. Why is that, you might ask? Let's start with gaseous water, like water vapor in the air, where the water molecules are very far apart. Notice all the empty space between the molecules, here, and so on. This represents very low density. On the other hand, look now at the liquid water on the bottom. Notice how all those molecules are so close you can barely see any space between them. So for the solid, this one, you would expect to see the molecules even closer together. And for most substances, that is the case, but not for water. Notice the considerable amount of empty space between the solid water molecules. Here, and so on. Not nearly as much as a gas, but certainly more than the liquid. This is why ice floats on liquid water. The solid is less dense than the liquid. Remember, that is unusual. For most substances, the solid state is the most dense. Let's now take a look at densities of various substances. Notice the gases are by far the least dense because the molecules of a gas are always far apart. The density of the liquids is much higher than the gases, as we'd expect, but still considerably less than the solids. Now, there are exceptions. For example, liquid mercury is very dense, about 13.6 grams per centimeters cubed. But generally, solids are more dense than liquids. And look at how dense gold is, 19.32 grams per centimeters cubed. That's dense. The unit we've been seeing for density is grams per centimeters cubed. You might also see grams per milliliter, kilogram per meters cubed, and many others. What they all have in common is density is always a mass divided by a volume. We'll come back to that formula in the next lesson dealing with density calculations, but for now, just consider it conceptually. That is, the density of a substance is not only its mass, and not only having to do with its volume, but how mass and volume are relative to each other. Let's see if you can apply what you've learned. These questions are not meant to require a calculation. Using all the information you see here about lead and gold, answer the 5 questions. Stop the video now. Okay, gold number 2 has the most mass of the 2 gold bars because both gold bars have the same density. They have to if they are the same substance in the same state of matter, and gold number 2 is larger. For number 2, gold number 2 has more volume because it's larger. For number 3, both gold bars have a higher density than the lead bar. The lead bar has the highest volume because it's the largest. And finally, gold number 2 has the greatest mass. Although it is smaller than the lead bar, it's only slightly smaller. And since the density of the gold is a lot more than lead, hopefully it's obvious that gold number 2 has the most mass. Last question. 2 different metals are shown on the screen. Both samples have the same mass. Which has the greater density? Stop the video now. The smaller one has the greater density. If both have the same mass, then the smaller one has that mass concentrated into a smaller volume. In other words, the structure of the smaller sample is more tightly packed than the larger, like HDL compared to LDL. Well, that's it for density part 1. Thanks for listening, and see you next time.